Recording is done. Good morning. I welcome you all for another session of cryptography, network security, and cyber law. So today we'll continue our module 3 on key management, authentication, IP security, and security at transport layer. Now in today's session, which is session 4, we'll be discussing about authentication techniques. Now let's look at what is the agenda of today's talk. Now today we will start a discussion on what we mean by authentication, which we had introduced briefly in the previous session, and then we will see what we mean by one-way authentication, and we'll see the classification of one-way authentication, wherein we have two types. One is the password based authentication and the other one is certificate based authentication. And then moving further, we have another way of authenticating two entities that we call as mutual authentication. Now in case of mutual authentication, we have 4 topics to be discussed, out of which for this session we have restricted ourselves to just first two topics. That is the shared secret based authentication and the symmetric key based authentication. Now the authentication and key agreement and use of timestamps, which are part of mutual authentication, we'll be discussing in the next session. Now let's start with what we mean by authentication. Fine. Now before we proceed further, we'll see that at the end of the session you will be able to describe one of the one-way authentication techniques, which is a password based or a certificate based authentication technique, and also you will be able to explain mutual authentication using a shared secret key, that is a symmetric key cryptography, or you will be also able to explain mutual authentication which is based on asymmetric key cryptography. Now before starting or going ahead with password based authentication, let me first introduce you to or recall what we mean by authentication, and also we will try to understand the entities that are involved in this authentication process, and then move ahead with the password based authentication. Let me get rid of this. Okay. Now authentication is defined as a process in which the receiver is able to prove get the proof that, or he is able to verify that the message has come from a genuine source. Now let's say the source and the receiver are communicating with each other. The receiver is able to get the information, or is able to verify that the information or the message that is received from the source is an authentic source as it claims to be. Now the source is also called as principal, who is trying to prove his credibility, whereas the verifier, who is the receiver over here, who is trying to get the principal verified, or to whom the principal is trying to prove his identity, we call it as verifier. Now the source is the principal and the destination or the receiver is the verifier over here. Now what is authentication? It is a process in which the principal is trying to prove that it is the entity it claims to be. And to whom is this principal trying to prove? It is trying to prove to the verifier. Now authentication are possible in many ways. One in computer system, what we use is password in order to prove ourselves that we are exactly whom we are claiming to be. We provide a login along with the password details. And also we can use a passphrase in order to get authenticated to a particular system or a server. Now if you are trying to physically prove that you are the person whom you are claiming to be, in that case what do we use? We use an ID card. It could be a passport, or it could be an Aadhaar card, or whatever. Now over here let's try to understand that there are two types of authentication. Now the first type is one-way authentication. Now what is this one-way authentication? one-way authentication, let's assume that there is a client-server communication. Now this, what happens in this client-server communication? Obviously, the client is the person who tries to prove himself to the server, prove his credibility or authenticate himself to the server. Now what does the server do? The server, if it is able to verify whatever client login and password is provided to it, if it is able to verify it, it will say that the client is authenticated. Now over here the client is authenticating itself to the server. Now the server is not authenticating back to the client saying that okay, I am the person who is going to take your request and satisfy your request. Now only the client is trying to prove to the server its identity with the help of a password. Now this process wherein only one person is trying to prove himself to the other entity, we call it as one-way authentication. Now what do we mean by mutual authentication? Mutual authentication is counterpart of one-way authentication. Now what happens? Let's take the same scenario where client and server are existing. Client is trying to prove himself to the server. Now this is one communication that has occurred, and server is able to verify the authenticity of the client. Fine. Now what is the other thing that will happen in this case? The server will also prove its credentials to the client. Now client is able to get to know the fact that it is actually communicating to a genuine server, not to a compromised server, or not to a intruder or something like that. Okay. Now mutual authentication is wherein both the communicating parties, be it the client or the server or be it two hosts, both of them prove their credentials to each other. In one-way authentication, only one communicating party will prove itself to the other communicating party, or that's it. Now over here, let's see what are the various types of one-way authentication. Now over here we will be discussing two types of one-way authentication. One is the password based authentication and the other one is certificate based authentication. Now let's go ahead with discussing what we mean by password based authentication. Now password based authentication has been the most common mechanism to implement any authentication technique. Now we all know that in order to log in into our system, our own computer, we would have set a password, and once we provide the password, the system is able to prove that okay, you are a genuine person who is trying to access the system. Or it could be even in the case of your Gmail account, or it could be even in case of your mobile device, whatever. Everywhere we are able to provide a password and try to gain access to the system. Now this is a very common method to implement authentication. Now what exactly is happening here? Now to log in into a server, let's take the example of a client server communication. To log in into a server, what does the user do? He has to authenticate himself to the server. Now to authenticate himself to the server, the client enters his login name along with the password. Now the password is some sort of secret information that is known only to the client and the server. Now the password which is provided by the server helps the client prove itself. Now the login name, what does it do? The login name identifies the user, and the password over here helps the user to prove itself to the server along with the login name. Now this is all about password based authentication. We have a client and a server. Now client is providing his credentials and getting authenticated to the server. Now let's look at this example. Over here the client is Alka. She has provided a login name Alka and the password is whatever these set of characters. Now what happens over here? Now we have this database which is having a file. Now this file at the server, S represents the server, and this is the database present at the server. Now over here in this database we have a set of login names along with its passwords. Now when a client sends its credentials to the server receives it and verifies and maps it across with this particular file and checks if it is having an entry for Alka. Along with the having an entry for Alka, it will also verify whether the password provided by Alka or the client actually belongs to Alka. If it matches, then server gives client an opportunity to communicate, and server will take the request from the client. Now what are the drawbacks associated with this password based authentication technique? The first drawback is the passwords over here in this file which is stored on the server. We can see that they are all in clear. Whatever is the password provided by Alka, it is also present over here. They are matched and then checked for the authenticity. Now all these passwords are seen to be stored in clear. Now any person when Alka is sending a password can see that particular password. An intruder can see that particular password by gaining access to that message. Now eavesdropping is easily possible. Now the second thing is passwords are stored in the database in an unencrypted form. Now attackers can compromise the entire file of passwords. Now when you look at this, there are two places or loopholes in this particular password based authentication. One is during transmission an intruder can intrude and get the access to the password, and second is wherein the attacker is trying to gain this entire file of passwords which is stored on the server. Now we do not want that to happen. What do? Now we make a slight modification in order to tackle such an issue. Now what is that? Over here we can see that there is a property of hashing that is used in order to hide the passwords or convert the passwords into something else and store it in that particular database which is present on the server. Now why do we convert this? See, over here the client is again communicating with the server for gaining access to the server. Now what is the client providing? The login name, that is Alka. Along with that, it is not just providing the password, it is providing the hash of the password over here. Now this hash of the password is sent to the server along with the login name, and Alka and its hash of password are verified. Now this helps us to prevent an attacker from deducing the user passwords from both the cases. You can even try to hide the information during transmission, or you can make this information unintelligible even in the password file. Now both the ways we are able to tackle this particular disadvantage of the previous password based authentication. Now we know that hash has one-way property, and we also know how hashes are verified. Now moving further, we will see, we'll continue our discussion on password based authentication. Now let's look at what we mean by replay attack, and the next attack will be, next protocol that we discuss is the challenge response protocol. Now what is a replay attack? It is an attack that is possible over the previous improvision of password based authentication, wherein we were using hash of a password. Now what is exactly happening here is that the attacker can snoop the communications that are happening between the client and the server. The client over here is Alka and the server is represented as S. Now what do we mean by snoop? Snoop is nothing but eavesdropping, just listening to what is the communication occurring between Alka and the server. Now what does the attacker do? He tries to obtain the hash of the password that is being transmitted, and then he can use that particular message to replay it back to the server after some X amount of time, and trying to pretend as if it is Alka. That is, it tries to impersonate Alka. Now this sort of an attack in which one plays back all or part of one or more previous messages with an intent of impersonating a legitimate user is referred to as a replay attack. So, over here in this particular case, what is the attacker trying to do? He is trying to impersonate Alka and trying to gain access to the server. And how is he able to do it? He is trying to listen to the messages that are exchanged between Alka and the server, and he will make a copy of those messages. After some 2 to 3 hours of time, he will pretend to be Alka and send those messages to the server. The server will think that these messages are coming from Alka and try and give the access, because it is giving the right hash of a password. Now, moving further, we will see an improvisation over this password based authentication. Now that many of us are aware of the bank transaction. What do we do if we are performing an internet banking? First we log in ourselves by providing the password, and if we are interested to communicate further or perform a transaction, we get something called as OTPs. Now, same concept we are trying to explain over here. Now, why do we use an OTP? In order to prove that we are fresh, there is some sort of fresh challenge that is happening here. Now, in case of an improvisation over this password based authentication, which is called as challenge response protocol. Now, this challenge response protocol is used in order to thwart a replay attack. That is, the attacker should not be able to use the messages that it has snooped on and later use it for gaining access to the server. Now the server, whenever it wants to communicate with the client, when client wants to communicate with the server, it offers with a fresh challenge to the client. Now, what does the client do? In response to this particular fresh challenge, the client does not send its password directly, but what it does is it tries to prove that it knows the password. Now, how does it prove that it knows the password? Now, the server, once it is able to give back a reply to the challenge or response to the challenge which is posed by the server is able to know the fact that this client which is trying to gain access is genuine. It is able to verify. Now, such a strategy we call it as challenge response protocol. Now, let's look at this three message one-way authentication which is used over here. Now, over here there are two communicating parties, A and B, which are trying to communicate. Here, in the first message, A is trying to communicate its identity. Now, what does the second message do? It is coming from B. Let's assume it is the server, A is the client. Now, B will send a challenge to A. That means a server is sending a challenge to A. This challenge is what? It is a random number which is selected by the server and it is sent back to the client. Now, this random number selected by the server is also known as nonce. Nonce is a number that is used only once. Now, what is the next thing that happens? The client has to respond back to the server. Now, how does the client respond back to the server? Now, it will take that nonce which is sent by the server along with the password. It applies a function f over it and then sends it to the server. Now, this is a 3-message one-way authentication technique. Now, let's see what we mean by the function f. In the function f, there are a few properties associated with it. Now, given x and y, it is easy to compute f of x and y. Over here, x is what? Password, and y is the nonce. Now, this f of x and y is a one-way function. So, knowing f of this xy, it should be infeasible for others to compute the password. Now, given a nonce r, it should be infeasible to compute f of password along with the nonce, even if one of them knows these f of nonce 1, nonce 1, nonce 2 and nonce 3 and so on for the corresponding nonces. Now let's see how we can improvise this particular 3-message one-way authentication we discussed. Now the function over here in the third message that was transmitted from the client to the server, for this instead of f we are using a cryptographic hash function. Now this cryptographic hash function is applied over a concatenation, which is represented by two parallel lines, concatenation of the password along with the nonce r. This nonce r is sent by B to A in second message. Now there is a third way of dealing with this particular one-way authentication, that is with the use of a secret key and performing the encryption. Now over here the previous messages remain the same. A is trying to communicate or authenticate itself to B. So for that it is sending its ID and B is responding with the nonce, and what's happening here in the third case is the nonce is encrypted using the secret key that is shared between A and B. Now what is the secret key? It is nothing but the password that is shared between A and B. Now let's see another way of performing this one-way authentication. Over here we can see there is a change in the messages that are being exchanged. A is trying to authenticate itself to B. Now A has sent its identity to B. Now what is B doing? B is not directly selecting a random number and a random number which is called as nonce and sending it to A, but instead it is encrypting it with the password which is present with itself. The password is something that is shared between A and B and it is sent to A. Now what will A do? A will decrypt this password and then obtain that particular R value, that is the nonce value, and send it back to server. Upon receiving, the server will check whether this R actually is the one that it sent. Now if both of them match and access is provided, and B can say that A is authenticated to itself. Now there are a lot of properties that nonce numbers have. One of the first property that nonce has is it is random in nature. Now second thing is it is non-recurring value, and every time we select a new nonce, that is why we are able to avoid the replay attack. Nonce itself refers to the fact that it is a number that is used only once, and then nonce value is as large as 256 bits, and this provides a huge space or a large space of numbers. Now usually the sender and the receiver never keep track of the nonces that are used for validations. Now since there is a large space from which nonce can be selected, because the size of a nonce is 256, the probability that this particular that the same nonce be used twice is infinitesimally small. There is very less probability that two nonces will have same value. Now let's check out with what happens in certificate based authentication. In case of certificate based authentication, we have seen that the client will be using a public key certificate. Now there are again two ways of performing certificate based authentication. Let's check the first way of performing the certificate authentication. Now over here the scenario remains the same, wherein A is trying to authenticate itself to B. Now A sends her certificate to B. Now what does B do? B selects again a nonce value and sends it back to A as a challenge that A has to take up and resolve and send back to B. Now what does A do? Now once the certificate is sent, before sending a nonce, B has to validate this particular certificate that is sent by A. It performs certain checks over it. One is that it checks the validity period of this particular certificate it received along with the name of the person for which this certificate is issued. And also B will verify the signature of the certificate authority on the certificate. It checks whether the certificate is actually genuine or not. Moving further, now what happens in case once the nonce is received after all these validations positive, and then B is sending a nonce to A. Now there is a reply that has to be sent by A back to B. Now what does this reply contain? R is a nonce that is received from B in message 2. Now this nonce is encrypted by A using its own private key. Now what should B do on receiving this particular message? Obviously B has to decrypt this information using A's public key and compare this nonce with the actual one that it has sent. If both of them match, then we say that A is able to authenticate itself to B. Now let's look at the second way of certificate based authentication. Now over here A is sending a message to B asking B to authenticate itself, authenticate and provide access to B. Now this certificate sent by A, on receiving, obviously a check is performed as that of the previous case. It checks for the validity and identity of A. Then what does it do? B will select a nonce and then encrypt it using the public key of A and send it to A. Once this message is received, A will decrypt the challenge, retrieve the nonce and send that nonce R back to B. Now if this nonce is same as that of the nonce sent by B, then B is able to verify the authenticity of A. That is, authentication succeeds. Now this marks the end of one-way authentication, wherein we have discussed two types of one-way authentication techniques. One is the password based authentication, which had 4 flavors of it, and also we had certificate based authentication with 2 flavors. Now moving further, we will see what we mean by mutual authentication, and within mutual authentication we will be discussing 2 types. One is the shared secret based authentication and another one is asymmetric key based authentication. Now what do we mean by mutual authentication? We have seen that it is often required that both the communicating parties authenticate with each other. Now in case of an internet banking, the customer authenticates itself to the bank, and also the bank is able to prove that the customer is actually communicating with a genuine bank. Now this sort of communication wherein both the customer and the bank are able to prove their credentials to each other, we call it as mutual authentication. Now within mutual authentication, as we have already told, we will just discuss 2 topics for today, that is shared secret based authentication and the other one is asymmetric key based authentication. Now let us look at what happens in shared secret based authentication. Now again there are 2 entities who are trying to prove their genuinity to each other. A is trying that it is genuine to B and B is trying to prove that it is genuine, and it is trying to prove it to A. Now let us see how this communication goes further. Now in the message 1, A sends its identity along with a nonce RA. Now since this nonce is generated by A, we refer to it as a nonce generated by A. RA represents a nonce generated by A. Now what does B do on receiving this particular information from A? wherein this message containing A's identity and along with the nonce RA. Now B has to respond back to the message that it has received from A. Now first thing what it does is it selects a nonce RB, and also it performs encryption of the nonce that it received from A, which is RA, using a common secret which was shared between A and B, and sends this entire set of information in message 2 to A. Now what is happening in case of message 3? In case of message 3, A responds back with the nonce RB, but still its response that is sent to B is encrypted with the key that is shared between A and B. Now the question that arises over here is, A's response to B's challenge in the third message appears to be a complete perfect protocol, because every information over here is either in terms of encrypted in encrypted form with the secret key that is shared between A and B. But yes, this protocol has some flaws in it. Now let's look at the flaws and try to overcome these flaws. Now what is the flaw that is occurring over here? Let's say A and B are trying to communicate with each other, and C is an attacker which has entered the scenario. Now let's try to understand the scenario, attack scenario. In the message 1, C is impersonating itself to be A and sending a message to B saying that it is A, and it has selected a random nonce RA and sending it to B. Now what does B do? B responds to the challenge that is received from A by encrypting that particular challenge along with a secret key which is shared between B and A. Along with that, it also sends its own nonce, which is a new challenge sent to A, but it is actually received by C. Now what happens in the third message? The third message over here we represent it as message 1 dash. Now C attempts to connect to A, claiming it to be B. Now over here you can see that C is sending a message to A, and over here it is sending the identity of B along with the nonce RB. Now note that this message is the same message offered to it by B in message 2 as in the previous slides. Now what does A do? A will send back a reply to B, but actually it is received by C. Now what does this reply contain? It contains RB, that is the nonce which is sent by C to A saying that it is B, and then this is encrypted, and also it sends a new challenge RC. Now how does C respond to it? C uses the response from A to complete the three-way message authentication protocol. Now what does it do? It takes the nonce received from B and encrypts it and sends it to B. Now B is able to verify it and say that think that B is actually communicating with A, but rather B is communicating with C, and A is also communicating with C. Now let's look at what the attacker has achieved. Now C is an attacker and he has successfully impersonated A and B. This third message that was sent by C to B says that it is required to complete the authentication of C to B. Now over here C could not complete the response to B's challenge since it is required to compute the secret key of A and B. So hence C initiated a authentication protocol with A, presenting to A the same challenge it received from B. Now A's response to the challenge in the message 2 dash was used by C to convince B that it was A that was trying to actually establish connection with him. Now such an attack is termed as reflection attack because a fragment of message is reflected back for having the communication successful. Now that fragment is the nonce of B, that is RB, which is encrypted using the secret key. This fragment was being exchanged between B and C and also A and C. Now this attack is also called as parallel session attack. Now let's try to correct this particular protocol and try to avoid an intruder impersonating itself as a genuine communicating party between A and B. Now this corrected protocol works mostly on thwarting the reflection attacks. Over here the initiator and the responder have to draw a challenge from disjoint sets. Now what do we mean by drawing challenge from disjoint sets? A will use a nonce, it could be odd number nonce, and B will use a even number nonce. And also both of them try to handle these challenges in a different way. Let's say the responder, that is B, encrypts his challenge, and the receiver, that is the initiator, decrypts the challenge that it receives. Now over here we can see in the first message A is sending its ID along with the nonce, and then in the second message what's happening is using the key that is exchanged between A and B, B is sending back the nonce in an encrypted form and also a new challenge, that is RB, in again an encrypted form. Now what does A do? A will perform the decryption in order to send back the nonce which is selected by B. So over here it is performing decryption on the message that is received from B and get back the nonce or the challenge received from B and send it to B. Now this is a protocol which is corrected and it overcomes the reflection attack or the parallel session attack. Now let's look at what happens in asymmetric key based authentication. Over here we assume that there are two communicating parties, A and B. Both the communicating parties have public private key pairs. Now obviously in asymmetric key cryptography both the communicating parties will have two keys, and these keys are related to each other. That is why we refer to them as public private key pairs. Now over here we will use a notation M and A. The message M sent together with A's signature on M. Now this is what this notation actually means. Now let's see how this how this authentication works. Now again we see this authentication in three ways. One is the flaw that is present in the protocol, and then the possible attack, and also then we will see how to correct this particular protocol. Now over here in the case of the first message, A is sending its identity along with a challenge, that is nonce RA, along and also A's certificate. Now what does B do? B receives this information, verifies the certificate of that it received from A, and if it is able to validate the certificate that is received, it will send a reply to A. Now what does this reply contain? It contains the string obtained by concatenating RA. Now what is it doing? It is concatenating another new nonce with the one that it has received from A, and then what is it doing? It is signing it with B, and then along with that it is also sending B's certificate. Now the third message, after A receives, it has to respond back. And how is it responding back to B? Now A is sending the nonce that is received from B by A by signing it. Now let's see how an attacker is able to deploy himself into this scenario. Now A initiates the communication with the first message, and this message is actually intended to B. Now what is A saying? A is sending its identity along with a challenge which is called as RA. This is a nonce that is sent from A to B. But this message, which is actually coming from A, which has to be received or sent to B, is in the middle received by an intruder C or an attacker C. This attacker will replay this message which has come from A after some time to B. Now he replays the same message to B, which contains the identity and a challenge RA. Upon receiving this message, B responds to A's challenge. Now what does B do? It selects a new nonce and appends itself to the previous nonce that it has received from A, but actually it has received from C, and then it signs this particular message and sends it to A. Now before reaching A, C is capturing that particular message, and what it does is, after capturing this particular message, it will retain a copy of it and it changes this to some other information. Now what is it doing? The nonce or the challenge it received from B along with the one that it received from A, both of them are signed by C and then sent to A. Now upon receiving, A has to respond to C's challenge thinking it is coming from B. A thus completes the mutual authentication with C by sending the third message. Now what does this third message have? Now it has retrieved the nonce received from B and signed it with itself and signed it with A and sent to B. Now this message halfway is received by C, and then C will then forward or replay this message to B. Now what is exactly happening in this situation? Now over here we understand from this particular figure B, which says that the message 1 is sent by C includes A's identity and attempts to convince B that the message is actually come from A. And what does B do? B will respond to what appears to be as A's intention to communicate with him. And then A may not be actually wishing to communicate with B and is not aware that C is attempting to impersonate itself on her behalf. Yet B receives a message 3 dash, over here you can see 3 dash. B will receive it from C, but actually thinks it is coming from A. He feels A intends to communicate with him since the message 3 dash contains her signature on the nonce chosen by him. Now how do we correct this scenario and try to avoid this particular attack on the protocol? Now one solution is that the entities include the identity of the recipient in all the messages. How is that done? A is communicating its identity along with the challenge nonce RA. Now what happens in the second message is that B will respond back with its new challenge along with the actual message it received from A, and this entire stuff is signed by B and then sent to A. Now what does this signing refer to? Signing refers to that B is using its private key in order to perform this signing. And then upon receiving this message, what does A do? A will again respond back to B. And what does it respond back? It will respond back B's identity along with the nonce it received from B, and this entire message is signed by A. and that means A uses its private key to sign this particular information and send to B. Now over here, since the identities of both communicating parties are involved, we are able to avoid the previous flaw in the protocol, wherein an attack could be posed. Now we have come to the end of this particular session, wherein we have understood the two one-way authentication techniques, which is the password based authentication technique and the certificate based authentication technique. Followed by that, we have also understood what we mean by mutual authentication technique, and within this mutual authentication technique we have seen what happens if we use a shared secret based encryption technique and asymmetric key based encryption technique. Now we close this session, and if in case you have any doubts or any queries, you can respond over this particular email or this particular mobile number. Thank you.